Hello, welcome back in another video. In this video, we'll speak about the vector geometry. Vector geometry is a fundamental area of mathematics focusing on quantities that have both magnitude and direction. These quantities, called vectors, underpin many scientific and engineering disciplines. Understanding vectors allows us to describe physical phenomena, model real world situations, and solve complex problems efficiently. In this guide, we will explore the basics of vectors, including their key characteristics, how to represent them, and their crucial applications in fields like physics, computer graphics, and engineering. Understanding vectors. What is vector? A vector is a quantity defined by both its magnitude, size, and direction, unlike scalar quantities which have only magnitude. Representation. Vectors are commonly depicted as arrows starting at an initial point and pointing towards a terminal point. Whereas the arrow's length shows magnitude and its orientation indicates direction. Notation. Vectors can be written using bold space letters, an arrow above, or as ordered pairs, 2D or triples, 3D. Example, a car's velocity of 60 km per hour heading north is a vector with that speed as magnitude and north as direction. Vector components. The components of vectors, breaking down vectors, any vector can be decomposed into components along coordinate axes, allowing easier computation and visualization. This makes it simple to work with multiple vectors or apply mathematical operations. 2D components represented as example 3 means 3 units along x-axis and 4 units along y-axis. This corresponds to an arrow drawn from origin to point 3 to 4. 3D components represented as example 1, 2, minus 1 extends into third dimension for depth. 3D vectors are essential in physics and computer graphics for representing spatial information. Magnitude and direction. Calculating magnitude, 3D magnitude, determining direction. An example of this is the vector has a magnitude of 5 and direction approximately 53.1 degree, showing a precise geometric interpretation. Vector operations addition, geometric addition, algebraic addition, properties, application. Now, if we take geometric addition, vectors are added graphically by placing the tail of the second vector at the tip of the first, tip to tail method. And second, algebraic addition. What is that? Component wise addition in simply adding corresponding components. Properties. Vector addition obeys commutative and associative laws. The order of addition does not affect the error results. And fourth, application. This operation models resultant forces or combined velocities in physics, aiding problem solving in multiple vector scenarios. And vector operations, scalar multiplication. The definition of this is scalar multiplication involves multiplying a vector by numerical scalar, affecting its magnitude but not inherently its direction. Effects on magnitude. Scaling up increases vector length proportionally. Scaling down reduces length. Negative scalars reverse vector direction. Example, multiplying 2 yields doubling each component and length. Use case. This operation is vital for adjusting vectors in applications like computer graphics to represent resizing or directional changes efficiently. And dot product. The definition of this is the dot product of two vectors A and B equals, or algebraically same like this. You can see the equations here and the results. The output is a scalar, not a vector, which carries information about the vector's directional relationship. And application uses to find angles between vectors, project vectors onto others, and text. orthogonality in physics and engineering. And conclusion is the core concept understanding magnitude, direction, and operations such as addition and scalar multiplication is essential for mastering vector geometry. Problem solving tool. Vectors allow simplification of complex physical and mathematical problems through elegant geometric and algebraic methods. Broad applications. From physics and engineering to computer science and graphics, vectors provide a powerful language for describing and analyzing multidimensional quantities. And thank you. That's all for today.